Assalamualaikum. Today's topic of presentation is prisms. In this topic, we will be covering the definition of a prism, the image formed by a prism, the orientation of a prism, the units of a prism, the primary position of a prism, and the uses of a prism. So let's start with the definition. So what is a prism? It's a refractive medium that is bounded by two plane surfaces inclined at an angle. Now this angle is known as the refracting angle, and the line bisecting this angle is known as the apex. There are some terminologies that you should be aware of. First is the apex, the base, the refracting angle, and the angle of deviation. So if you look over here, this is the apex. So this is the thinnest part of a prism, and it is formed when two plane surfaces meet. The image is also formed at this part. It's closer to this part. So the part opposite to it is known as the base of the prism, and it is the thickest portion. Now the orientation of a prism is mainly determined by the direction of its base. As I said, the refractive angle is the angle formed between two plane surfaces, as you can see over here, and it's denoted by alpha. And the angle of deviation is the amount by which the light deviates from its original path, measured in degrees. So if you see here, light is incident upon a prism, it is refracted, and then there is an emergent ray. So if you also notice that the rays deviate towards the base, like over here, and you will see an image more towards the apex, and over here is your angle of deviation. Talking further about angle of deviation, it depends upon three things: the angle of incidence, the refractive angle, and the refractive index. So as I've already told you that the orientation is determined by the direction of the base. So as the base is down over here, this is a base down prism, base is up, so base up prism, base in, and a base out prism. So now talking about the image formed by a prism, it is erect, virtual, and displaced towards the apex. So light from an image over here is the incident ray. It would be refracted in the prism, and as I've already said that it would be deviated towards the base. But the image will be formed towards the apex, and the eye has to move towards the apex in order to see the object of fixation, and the amount by which it moves is equal to the angle of deviation. These are also the actions of the prism, as I've already said over here. Incident ray is deviated towards the base, image would be displaced towards the apex. I would move towards the apex, and it would move by an angle, move by amount equal to the angle of deviation. And light obeys Snell's law. You have already discussed it in your introduction. Characteristics of a prism: when light passes through a prism, it is dispersed into its component. The prism does not change the divergence of the light, and the prism also does not increase or decrease the size of an image. Okay, so now talking about angle of minimum deviation. If you look at this picture, when light passes through a prism, it is deflected twice, once while entering and the other time while emerging out. Sum of these two deflections is the angle of deviation. So now when your incident ray is equal to the ray of emergence, the angle of incidence is equal to the angle of emergence, your refraction is symmetrical and you will have minimum angle of deviation. And this angle, minimum angle of deviation, is half that of your refracting angle. So now there are two primary positions of a prism, the Prentice position and the position of minimum deviation. So in the Prentice position, one surface is normal to the rays of light, so deviation only takes place at the other surface. So your angle of incidence is not equal to your angle of emergence in this case. While the position of minimum deviation, you hold the prism perpendicular with its back surface perpendicular to the object of fixation. This roughly coincides with your frontal plane position in practical use. If you look at an example, the glass ophthalmic prisms are held in the Prentice position, which include the tri-lenses, while the plastic ophthalmic positions are specified for minimum angle of deviation, which includes the prism power. So if a prism is placed in the Prentice position, its power would be more as compared to that in the minimum angle of deviation or the minimum deviation position. So for example, if you have a 40 diopter prism and you hold it in the frontal plane, which is your angle of minimum deviation, the power would be 41. But if it's held in the Prentice position, its power would be 72 diopters. So here are some units of the prism. The first is the prism diopter. So a prism of 1 diopter would produce a linear displacement of 1 centimeter placed 1 meter away from the prism. It's signified by the delta symbol, which is given over here. The next is the angle of apparent deviation. So this say the prism of one prism diopter would produce an apparent angle of deviation half a degree 1 meter away from the prism. Next unit is the centrad, which is that a one centrad prism would produce an apparent angle of displacement about 1 centimeter. So this is basically an arcuate apparent image, 1 meter away from the prism. Here you can see the sign by which it's denoted. Okay, so the vector addition of a prism. Sometimes you would need correction in both horizontal and vertical direction. So what do? You take a stronger prism mounted in an oblique angle. How will you find the power and the angle required for it? This can either be given graphically or mathematically. So in graphically, you will draw the powers to scale and complete a triangle, or you can give it mathematically by the Pythagoras theorem. A square B square is equal to C square. So if you look over here, if you want this angle right over here, you would take tan ROH is equal to RH over OH, which is RH over here, your perpendicular over your base. Okay, and if you need this value over here according to Pythagoras theorem, and if you still use this example, you would take 3 square plus 4 square and then take the square root. You'll get this value. So over here they have given an example. A 5 diopter base up prism lying in 37 degrees is equal to a 4 diopter base in prism plus a 3 diopter base up prism. Talking about the Rispy's prism, these are two prisms that are wedge shaped and they are mounted one in front of the other, and they can be rotated with respect to each other. So the total power will depend upon the vector addition, which is indicated on the rim. This is used in conjunction to Maddox rod and in the refractor heads. So how would you measure an angle of squint when it's given in the orthoptic reports? You can use a synaptophore, or you can or by the prism cover test. So in synaptophore, the angle of prism is expressed in degrees. So if we look over here, synaptophore with our glasses, plus 20. So plus would specify. Can anybody tell me what is it?
Exo.
Exo. And minus is exopus. While in prism cover test, it's expressed in diopters. So distance diopters plus 40, which means esotropia is 40 degrees. So now moving towards the uses of a prism, these can be divided into diagnostic uses and the therapeutic uses. So let's discuss the diagnostic uses first. You can use it to measure the angle of the squint, the likelihood of diplopia, fusional reserve, the 4 diopter prism test, and to assess the stimulated blindness. Just talking about I will not cover them in detail, just how to perform them. So first, the prism cover test. So how will you do it? You measure, you give the patient a target. This can be for near or for far, done in all directional cases. First, you perform the alternate cover test. So what you do, you would measure the amount and the direction of the deviation, and basically you're producing a dissociation between the two eyes. So after you've done your cover test, the alternating cover test, you'll place the prism. Now, can anybody tell me what would be the direction of a prism if there's esotropia? Over here,
towards deviation.
Yeah. Okay. So the apex will be towards the deviation. So if it's an esotropia, you're using a base out prism. So you'll place the prism in front of the eye and you'll perform the alternate cover test. You'll gradually increase the strength of the prism until your neutralization point is reached. What does that mean? That means that you will not have any movement. And if you increase the strength, then there would be a reverse. Okay. Now talking about the Maddox rod and where the prism is used. So if you consider this eye the left eye has an esotropia or an exotropia, the Maddox rod that would be, okay, so basically the Maddox rod is a series of cylinders. So if you have horizontal lines over here, and when you shine light into the patient's eye, you would get a vertical line. So what happens is you place the Maddox rod, if there's any if there's any esotropia and exotropia, in front of the eye, and you shine light into the patient's eye. So this would dissociate the two eyes. So now what happens if here your right eye you put the light in the eyes, your right eye would see a white dot and your left eye would see a vertical line. In case of esotropia, the vertical streak is uncrossed. However, in exotropia it would be crossed. Same is for if you have any hypertropia or hypotropia. If they are dissociated, you would see a white line. The patient would see a white line. In hypertropia it's above, in hyper it's below. So now what happens is, you first place a Maddox rod in front of the eye, shine light inside in the patient, expose them to light. So if this is a right esotropia, over here in your left eye, the light is falling or the light is stimulating the fovea, but over here as you can see it's not in the foveal position. So you'll place a prism in front of the eye until the patient says that these two are superimposed. So that now you will find out your angle of deviation. So fusional reserve is used to check how much vergence a person has in reserve in order to overcome hypertropia. So we give an example to this. So we'll ask the patient to fixate at a target placed at 33 centimeter distance. So for example, if the patient is looking at this target, which is the letter E, so you have to use horizontal prisms, which means either base in or base out prisms. So if you're checking convergence, you will use, which prism would you use if you're checking convergence? Base in or base out? Base out. Okay, just type the deviation of your side by epics होगी. Okay, so you're checking the convergence, you're using a base out prism. So what happens, as I've already said, when light passes through a prism, it moves more towards the base, right? So now it's not stimulating the fovea, the eye would have to converge in order for the light to stimulate the fovea. So what do? You keep on increasing the strength of the prism gradually, and you will ask the patient to report a blur point. So for example, in that picture, the patient is seeing the letter E, you'll ask them at which point does the letter E appear blur. You'll keep on increasing the strength of the the prism, and you'll ask them at which point does the E become doubling, there's doubling of the image. That is your break point, that means there is no vergence movement. Once you reach this point, you'll decrease the strength of the prism. Now when the patient says that they can see a single image again, that is your recovery point. So again, distance target to fixate karwaya, you place the prism. If you're checking convergence, you'll place a base out prism. You gradually increase the strength until your patient says now the image is blurred. Now they see a doubling of image, and now when you decrease the strength, they would say that there's a single image again. Or this is when you check convergence, that's your positive fusional reserve, and for divergence is the total opposite. And you perform it in a similar way. Okay, next is the four-diopter prism test. So now this test is for a small degree of esotropia. What is a small degree? That could be any deviation less than 10 diopters. Okay, so now what do? So a four-diopter base out prism is placed in front of the deviating eye, will cause no movement as the image remains in the suppression scotoma. What's a scotoma? Can anybody tell?
Area of the field within the area.
Yes, and suppression is your cortical mechanism by which the brain suppresses any image that could lead to diplopia or confusion by the deviating eye. Right, so if you look over here, so assuming that this person has a bifoveal fixation, so when you place a base out prism, because it's esotropia, so you're using base out prism. So if you place, and assume this is the right eye and this is the left eye. So if you place a four-diopter base out prism in front of the right eye, what would you see? If you consider this picture, so as the light moves a bit temporal to the fovea, the eyes would converge. So yani they would move towards the left. Now by Hering's law, your left eye would also move towards the left. But as I've said, this bifoveal fixation, it has to regain its fixation, fovea simulator. So what will happen? The eye would move again towards the right. So if you sum it up, if you place a prism in front of the right eye, there is an initial version movement, which means the eyes are moving in the same direction. In this case, this is the left. But in order to regain fixation by the left eye, there will be a vergence movement, which means now the eyes are moving in the opposite direction. In this case, it will move slightly towards the right. So now let's assume that the person does have a small degree of esotropia, which is a microtropia, in the left eye. So when you place a base 4-diopter base out prism, what would happen to this eye?
Converge.
Yeah, it will converge. Okay, and what would happen to this eye according to Hering's law? It will also move out. But we've already said that in this case, the eye has a suppression scotoma. So if you look over here, even if the light falls over here, there will be no movement. Right? So what would you have? You'll have your initial version movement, which means everything, both of the eyes will move towards the left. But there will be no refixation movement, so there will be no vergence movement. Now, if you place the same prism in front of the left eye, as I've said, there is a microtropia in the left eye, there will be no movement because the light is stimulating the suppression scotoma. Right? So no movement at all. Okay, and to check the stimulated blindness, what you would do, place the prism in front of the eye, it will move if it's a seeing eye. Right? Okay, so if there's convergence insufficiency, what prism would you use? You need to move the eyes inward. So yeah, face out. So like over here, we are using face out prisms, and they're not constantly worn only during the exercise period, right? Okay, so now one of the other uses is to relieve diplopia in cases when surgery is not indicated, for example, vertical squint, paralytic squints, or decompensated heteropholias. So what are the forms of prism? They can be temporary or permanent. So in temporary, you can clip them on your trial frame, for example, the Fresnel's prism. These are tiny sheets of parallel prism of equal refracting angle. The overall prismatic effect is the same. Now they can be stuck onto the glasses. What are the advantages? They are thin, light, flexible, they can be cut into any shape, and they reduce the magnification difference. The disadvantage is that they are harder to clean and there's slight loss of visual acuity. How would you permanently incorporate a prism? They can be mounted onto the spectacles. Okay, now prescription of a prism. The correction is split between the two eyes, and again, apex is displaced towards the direction of deviation, as we already know. So to correct convergence, you would use which prisms?
Base out.
Base out prism. To correct divergence, which prisms would you use?
Base in.
Okay, and for hypertropia, when the eye is upward, base down. And for hypo?
Base out.
Yes, that's the same thing. Okay, so the last topic includes the prisms used in optical instruments. So they use as reflectors and they're designed in such a way so that total internal reflection occurs. Can you give examples where the prisms are used in which instruments? Absolutely. Okay, so two prisms that are commonly used, the porous prism. So this is a reflective prism used in pairs. So the second one is oriented 90 degrees to the first. So what happens is when light passes through the prism, the image is rotated 180 degree and it's inverted and reversed. So you can look in the light as the object and the image is rotated 180 degree, inverted and reversed. So they are used in telescopes and in slit lamp. The other one is a Dow's prism. Again, it is also a reflective prism and it inverts the image. So these are basically truncated right-angle prism. Light enters from one sloped surface, undergoes total internal reflection, and emerges out from the other side. So this also inverts the image, but it is not laterally transposed. This is used in astronomy and in interferometry. So there are some MCQs. Now you will tell the answer.
See?
Yeah.
Mm.
Okay. See. These were the references used. Thank you.
Light on the. Okay, so mobile की light off करते हैं. See, 2 weeks back I was doing SPPS ophthalmology Viva, and I had a case of hypertropia. And we examined 2 cases on long case and about 8 cases on short case. And only one candidate was able to handle the prism bar correctly. So they were not able to understand which way to put it. I was deviated up, so the apex had to be up. There are 2 prism bars. One is for horizontal prism deviations and the other is for vertical. So half of the candidates would pick up the horizontal ones to measure the vertical. So you have to practically handle the prism bar so that the examiner knows that this is not the first time you are holding a prism bar. So you come in the orthoptic department and examine a few cases with prism bar. 4 or 5 cases are sufficient. So this is one thing. Secondly, the prism bar testing is a must if you get a case of squint, you have to assess the amount of squint, and that is not possible because synostophore, we used to have synostophore in our department. We used to measure the angle of squint with synostophore. It's not available now, so you have to use the prism bars. So this is the most important instrument for accurately measuring the angle of squint. So these were all intentional uses of the prisms. So you said Fresnel prisms or the prisms incorporated in the glasses can be given for therapeutic use. Another way of producing prism is to decenter the glass. So if you have, let's say, +10 lens, the margin acts like prism. So if you displace the lens up or down, it will behave as a prism. So you can incorporate prism by decentering the lens. Now here comes the problem. High powered lenses, whether they are plus or minus, if they are not centered well in front of the pupil, the center is above or below or right or left, they will produce prismatic effects. And this is the commonest cause of intolerance of glasses.
It's really unbearable guy. Like a patient came, उसने कहा कि मेरी आँख जो है ना वो बाहर जाती है एक्सो में, और वो उसकी मतलब कि उसमें भी रिसेप्शन ऑफ लाइट थी सिर्फ, ठीक है, ओल्ड ट्रॉमा की हिस्ट्री थी। वो कह रहा था कि मुझे सिर्फ ये आँख को जो बाकी मुझे ऑफिस वर्क में प्रॉब्लम होती है कि सिर्फ जो ऑडियंस मुझे देखा वो समझे कि आँख सीधी है, बाकी इसमें मेरे को इम्प्रूवमेंट चाहिए।
The best solution is to have surgery, but the promotion of surgery is not good. वो दोबारा डिग्री तो ये इतना अगर ज़्यादा स्क्विंट है और कितना प्रिज्म आप लगाएंगे तो वो आँख सीधी लगेगी, मैंने वैसे प्रैक्टिकली नहीं देखा। जिस आँख में नज़र हो वो तो फिक्सेशन टेकअप करेगी और उसको आप मूव करा सकते हैं कि जी उसको अंदर की तरफ मूव कर दे बाहर, जिसकी डीएनए नहीं है वो फिक्सेशन टेकअप नहीं करेगी।
सर लेकिन इसमें सिर्फ मैं कॉन्सेप्ट डिस्कस करना चाह रहा हूँ कि प्रिज्म आपको बेसिकली इमेज की पोजीशन अल्टर कर देता है ना, तो मतलब टुवर्ड्स द जो है वो आपको एपेक्स इमेज शिफ्ट कर देता है कि प्रिज्म ऐसा लगाया जाए कि जो सामने बैठा बंदा उसे देख रहा है वो समझे कि इसकी आँख सीधी है।
नहीं, मैंने सुना नहीं है इस तरह का इस्तेमाल। वो प्रिज्म ज़्यादा इसीलिए यूज़ करते हैं कि अगर वीन इतनी अच्छी हो कि वो फिक्सेट कर सके तो फिर उसका जो एंगल ऑफ इसमें दो तरह के यूजेस हैं प्रिज्म्स में। एक तो ये है कि आँख टेढ़ी है, अब आपने ये करना है कि जी फर्स्ट करो कि उसको